For people who follow disappearance of Katie Middleton. And if you follow those news, you will find on the end, somewhere on those same web pages, a small news about solar eclipse. It kind of goes together. So we are, or you are lucky enough that you will see real solar eclipse in your life. If you live long enough, you may see two of them, but most of the people see one or 1.5, not complete solar eclipse. So because we have this solar eclipse happening April 8th in our neighborhood, we have two students who are part of our astronomy club who took some time to prepare for you something about solar eclipse. Benjamin Eunice and Katia Roach will show you what solar eclipse is, why you should go at the place to see one, because it's closed, and what you are actually going to see. Or not to see because the sun will disappear. So what you are not going to see.
For thousands of years, solar eclipses have fascinated humanity. We absolutely love these things, and we've been terrified with them for as long as we can remember. In around 500 BC, there were two nations in modern-day Turkey, the Lydian Kingdom and the Median Empire. These two nations had been warring for around 5 years, not really making any progress on each end. There have been many bloody battles, and this had been something of a kind of deadbeat war. This had kind of started because of some distrust that had been developing between these two empires, as the Median Empire was expanding from the east towards the Mediterranean Sea. One of these battles near the Patera region, the Halys River, was an event that started like many of the other battles of this war. People, around noon, these battles starts, and many people no one was making any ground. Bloodshed was rampant. As the sun was getting lower in the sky, however, people started to notice something a little bit concerning. The sun was rapidly disappearing. People began to panic. People thought, what's going on? The gods must be enraged at this violence. At the end of this, the war and the battle began to subside, and a peace agreement was drawn up, ending the 5-year struggle when the princess of Lydia was married off to the Median king. This is known as the Battle of the Eclipse. And what's really interesting about this battle is that this is the earliest date that we have for a specific day. And the reason being is we can roll the clock back and determine exactly which eclipse happened and when it happened. So this battle happened on May 28th of 585 BC. Some of the other interesting cultural aspects of solar eclipses back in the Babylonian era, some of the earliest astronomical readings and development were happening in this region, and the Babylonians often found these solar eclipses to be omens of bad times, strife, and plague. So when the Babylonians would the Babylonian astronomers would go to the king and say, hey, there's going to be an eclipse. It's going to happen within a few days. The Babylonian king would appoint a faux king, a false monarch, and a full court and protection for this monarch. Would install them as king, and then the real king would go and pay almsgiving during this period. If the eclipse came to pass 100 days following this eclipse, the real king would re-enter the court and violently murder the fake king, hopefully cleansing the kingdom of any of this bad mojo. Fast forward about 2,000 years, the Age of Enlightenment, and one Edmund Halley of Halley's Comet fame is reading an interesting piece, Principia Mathematica, by one Isaac Newton. For those of you who are not really as familiar with this, what's so important about Isaac Newton's Principia Mathematica, also known as Newtonian mechanics? This allows us to do some relatively profound things that were not able to be done before this was developed. For instance, the real profound thing to keep in mind about it was the fact that it connected the motion of simple projectile motion. If I were to throw this mouse across the room, and I could predict its arc, its motion, and where it would fall down, even keeping in mind the curvature of the Earth. It can also predict the motion of stellar bodies, such as, in this case, the moon. So Haley thinks, okay, I'm going to use this new mathematical model to determine when this solar eclipse is going to take place. And when he released his prediction, he had released the most accurate prediction of solar eclipses up until this time, being only 4 minutes off of what was actually observed in the locations. So this kind of stuff is very difficult to determine. It took up until the invention of Newtonian mechanics to figure out kind of the madness, because it seems, if you've ever looked at where a solar eclipse happens, this one's happening in England, there was one happening in modern day Turkey, and the one on the April 8th will pass through the United States. And there is a method to this madness that allows us to understand why this is happening. Now, to explain this madness, I cast it off to Katia and Roach.
Yeah. Now, the geometry of an eclipse is something that can seem across complicated and very convoluted, but broken down, it's pretty simple and easy to understand. The first thing to understand is that what is exactly an eclipse? Well, by definition, it's the part or total blocking of a celestial body's light by another. And of course, in our celestial dance, we're talking about the sun, moon, and the earth. Now, there's not a lot of components that go into the different kinds of eclipses, but first we're going to talk about the solar eclipse. So first, we have what's called the umbra and the penumbra. So when the sun shines its light on the moon, the shadow that is cast, the most direct and concentrated shadow that we see, is the umbra, the highlight of any solar eclipse. And of course, the secondary shadow that most of the other people see is the penumbra, which isn't the complete eclipse, but I'll explain more. When we look at the partial solar eclipse, to understand, the moon is on the line of the umbra, only partly falling within that concentrated shadow. So yes, a part of the sun is covered, and you do get a partial eclipse, but it is never fully covered. Another type of solar eclipse is actually an annular eclipse. Now, an annular eclipse, the moon does fall within the umbra of the concentrated shadow, but because of the Earth's elliptical orbit, some parts of the moon are farther, well, a part of the moon is farther away from the Earth than in other areas of the Earth. So we can see the ring of fire around the sun, not completely covered, still giving us that reddish, orangish, yellow glow. And of course, the star of every show, we have the total eclipse. Now, what makes this so special is because you have to be at the perfect place, at the perfect time, and the perfect part of the world to see such a thing. The total eclipse, you have the moon fully covering the sun's color, and you're left with a whitish glow, a ring of white. And you may be asking, why is not red? Why not yellow? Why not orange? The color of the sun that we see every single day. Well, with the moon covering it in such a way, we're allowed to see something that you can't see with the naked eye, which is called the stellar corona. Now, the stellar corona is the ionized gas of the outer atmosphere of our sun. Now, every other day when we look at the sun, which you shouldn't, you will just see a bright light with the color. But because of that so brightish light, you can't see the stellar corona emitted from our sun. Now, since all that light is blocked off, it's dimmed, and the color is no longer there. And the sky, by the way, is extremely dark. And this is a lot brighter in picture than it is in real life, but you can still see the stellar corona. Another interesting thing about the stellar corona is actually it allows you to see the magnetic fields of the sun with the naked eye. The reason being is because the ionized gas, the plasma, follows the magnetic field and you can physically see it, which is extremely exciting and something you can only see once every couple hundred years. Now, of course, April 8th, 2024, soon coming up, we have our own solar eclipse coming here to the United States. And this is a map of actually the path of totality that it will be taking throughout. You can see it in some parts of Canada. Here, of course, is the concentrated umbra, where you will be able to see the total solar eclipse. And then the outer areas, you will be able to see a partial eclipse, which is super exciting. Now, of course, solar eclipses aren't the only kinds of eclipses. We also have lunar eclipses. And as you can see, we kind of changed celestial organization with the sun, earth, and the moon. And of course, the earth is a lot bigger than the moon. So the shadow that's casted, the concentrated umbra, is much wider and covers completely the whole moon, and the penumbra is also much wider. Now, because of this, 50% of the earth can see lunar eclipses, which only happen at night. Now, of course, there are different parts of lunar eclipses. First, we have the penumbral. The penumbral eclipse does look like a regular moon in the sky, even though there may be a lunar eclipse going on somewhere else. This falls in the penumbra of the shadow. We have a partial, which means the moon falls within the umbra of the shadow. And then we have a total lunar eclipse. Now, what is special about the total is, you may be asking, why the reddish, yellowish color? Why not a bright white or something different? Well, since the sun is shining all of its light on Earth, and the Earth is blocking all the light from the moon, all the Earth's light rays have to go through Earth's atmosphere. And because of that, our atmosphere actually scatters all the blue light and reflects the reddish light onto the moon. Now, a fun little fact is the more clouds and dust in our atmosphere at the time actually determines how red the moon will be. And so some cloudier nights, it can be redder, it can be dimmer. It kind of just depends on the weather at the time. Now, taking a little pass back to Benjamin, he'll tell you a little bit about rarity.
So one of the things I'd love to impress on everyone is just how rare an eclipse, as close as it is to us, is. At any given point on Earth's surface, a solar eclipse will really only come to pass every 350 to 450 years. In our case, we are lucky enough to have a path passing within about 3 hours drive from Ruston. So if you have the opportunity to go with us or go with someone else, you should go see this. Please go see this, because this is something that is very, very rare. And as Katia had mentioned earlier in this talk, it's that these paths, due to Earth's, the tilt of the moon, is about 5 degrees off from Earth's orbit. And because of this, the moon often just misses the sun. It either goes above it or below it. That's what you typically see with a new moon. But with a solar eclipse, that's when the moon actually manages to cross in front of the sun completely. And that's something that on any given point on the Earth is pretty special. So I really want to impress on everyone, please try to go see this. These things are gorgeous and beautiful. So this is an example of an event that might be put on by a club known as the Astronomical Society. We are a brand new club starting this quarter at the university. So a couple of things that we might be doing is, obviously, we do astronomical work. We'll be working on the observatory, taking data, learning about that data, any number of topics about our wonderful universe. But if you're not into doing a lot of that stuff, it's a bit complex. How many people in here are not STEM majors? If you could raise your hand. Hey guys, thank you for coming. So for those of you guys who are not STEM majors, you guys are kind of the key to this. We really need artists, we need business people, we need poli-sci people, we need everyone from different walks of life to just enjoy the cosmos and add your voice to the conversation. We need people to do that, because I can't draw, and I can't show these things to people in a way that's really cohesive, but I might be able to have someone else come and do outreach and say, hey, this is a really beautiful drawing of maybe what a solar eclipse is or what a lunar eclipse is, in a way that's better than me with my free body diagrams will do. So I would really encourage everybody, get your friends, especially your non-STEM friends, to come and enjoy the cosmos with us. Our first meeting will be this coming Wednesday in IESB 308 at 6 p.m. So if you'd like to come out, we'd love to see you and tell you all about it. All right, thank you guys so much. Y'all have been a wonderful audience.